All right, so I'm going to record these notes and see how this goes. Anyway, skeletal system notes, unit 3, chapter 7. How does the structure of bone help with its function? All right, we're going to start with the skeletal system. Some interesting fact. Babies have more bones than adults because over time the bones fuse, some bones fuse together. So babies have about 260 or over 260, where adults have 206. Makes up about 30 to 40% of our body weight. It's called dynamic because it's always changing. All right, we're always getting new cells, getting rid of cells. We're going to learn about homeostasis of calcium in our body. So that's where the bones are the most important, and it's designed to take a lot of force without breaking. So again, the structure is very important. Some of the functions of the skeletal system: it provides points of attachment, support and protection for softer tissues, such as the lungs and the heart. It produces blood cells. It stores inorganic salts, and we'll talk about calcium and so forth in a minute, or not in a minute, but in our next central question. And then it forms passageways for blood vessels and nerves. All right, how do we classify bones? We have long bones, which are, the long bones, femur, radius, humerus, things like that. Short bones, which are the carpals and tarsals. Flat bones are ribs and scapula. Irregular bone, it's also like our sternum is a flat bone. Irregular bones, no identifiable shape, is our vertebrae, and we have a round bone. It's called a patella, is the most common. And here's an example of all of them. So here's our sternum. Here's our patella, vertebrae, and our carpals. Let's see. All right. So we're going to go ahead and just identify the parts of a long bone. We have the epiphysis, sorry, that's towards the end, the head. And if those of you who have talked about, we'll talk a little bit about it in a couple slides about growing, and we have an epiphyseal plate, which is called your growth plate, your diaphysis, which is the long part of the bone, and where we have our periosteum, which is the connective tissue that covers the bone. So you can sort of see it along here. All right, so those are the three parts, major parts of the bone. How is it structured? Well, we have a compact bone along the edge, which is a continuous matrix with no spaces. And then we have our spongy bone, which is irregular connecting spaces and reduces the bone weight. They're both very strong. They have a very strong, high tensile strength, right? So we'll find that in a lab as well. This is just a breakdown of how the bone is broken up. Again, we won't get too much into this. It will be mostly an identifying yeah, so in our ID slides is what you need to know. All right. How does it develop in formation, bone development and formation? The process of hardening the bone, and this is what happens when we get, when we're born, our bones aren't as hard as they will get. So it goes through this process of ossification. It begins as cartilage, and then those osteoblasts are the bone forming cells, which form the spongy bone. Okay. The osteocytes, so we have osteoblasts, osteocytes are the structural cells surrounded that are surrounded by bony matrix, this extracellular matrix. All right, so they maintain the structure. Osteoblasts continue to form bone tissue to form compact bone on the surface of the spongy bone. All right, let's see. Intramembranous sheets are the sheets of the bone, and then the endochondral are the masses of the bone, which are so they're sheet bones. So for instance, the skull is a sheet. Most endochondral, which are the masses, most bones, osteoclasts, and we'll talk about. So we have osteoclasts, osteocytes, and osteoblasts. I know it's going to be a little confusing. Continue to break down and build up bone tissue during development. And again, we'll talk about homeostasis, how the osteoclasts break down the bone and the osteoblasts build up the bone. And that's all for, helps with calcium, the homeostasis of calcium. Again, this is that growth plate or epiphyseal plate. It's a cartilaginous plate that grows the extending bone. Eventually it ossifies, and then at that point, the person starts growing. Damage to this plate can affect child's growth. Joints. We're going to talk about joints and the different types of joints. These are junction between bones composed of connective tissue. We have three major classifications: fibrous, cartilaginous, and synovial. So fibrous, this is a thin layer of dense connective tissue. It's immovable, and those are the joints within the skull. You can see there's joints. We have different bones, and there's joints between those. Cartilaginous, these are limited movement and can be found with the vertebral column. All right, so here's your cartilaginous joints. I know I'm having a hard time pronouncing things. I can't even say the word pronounce because this is right before class. So synovial, these are the free movers, right? So we have, you know, all the free moving joints: elbow, shoulder, knee. Those are synovial joints. Usually we have a meniscus. The arrows were all messed up. So the tendons, we have the meniscus and then we have the bursa sacs, which I know this is a bursa sac, and then it provides shock absorbing. So different types of synovial joints. We have ball and socket, we have condylar, and we have plane. So the ball and socket, hip and shoulder, you can rotate them. Condylar, between the hands, the fingers, and then the plane joints between the carpals. All right, so so those would be those joints here, and then the condylar joints would be up here. The hinge joint, which are elbow, we have the pivot joint. We talk about the atlas and the axis, allows us to rotate our head, and then we have the saddle joint for the opposable thumb. And I think that's it. It was pretty fast joints, so I'll let you take these on your own, and we shall see you in class.